Okay, so in the last video, we got into the first layer of MAVLink, or the standard message structure. In this video, we're going to look at how we can change the message ID to vary the types of messages that are sent with the standard message structure. These standard message IDs will let the receiving MAVLink node know how to parse the incoming data and what action should be taken upon receiving the specific message ID. The standard also tells the sending MAVLink node how to package up the data into correctly formatted packets. If you want to check out the list of standard MAVLink messages, you can check out this link below, but let's get into a couple other examples. So to this point, we have been setting parameters with MAVProxy of our drone, but under the hood, MAVProxy is actually creating a MAVLink message with message ID number 23 and filling out the appropriate fields to satisfy our MAVProxy request. So message 23 has 5 standard fields that must be filled out. The first one is the target system ID of the MAVLink node that we want to set the parameter to. This will typically be 1 for the system ID of the drone. Next, we can fill out the target component if applicable, but this will most likely be 0. Now we have the param ID field, and we can see its type is a char array, indicating to us that we should specify the name of the parameter we want to change. So if we wanted to modify the RTL alt parameter, we would place that string in this field. After this, we can fill out the value we want to set the parameter to with the param value field. And finally, we can specify the type of the parameter. And then all of this gets packaged together and constitutes the data portion of the MAVLink message. And the message ID number 23 gets mapped to the byte index number 5 of the MAVLink header under message ID. And then this will get sent off, and once received by the drone, it will see message ID of 23 in the header and know how to parse the data portion of the message to fulfill the request. Let's check out another important MAVLink message, and this is command long, MAVLink message number 76. This is a very unique MAVLink message because it actually allows you to command the drone in hundreds of different ways with the same MAVLink message number 76. This is done by modifying the command field of the message. MAVLink provides us with a mav command enum, which essentially maps a number to a unique command. So for example, the mav command enum maps the number 21 to the command to land the drone. So if we send a command long message with the 21 in the command field, the drone will land. There are many other commands that we can specify, some of which we may require some additional information. Here at the top, you can see a deeper look into command number 21. And as you can see, we have some parameter values that we can specify for the particular command. These are not parameters like we've been talking about to this point. These are simply parameters that define the command that we're sending. These can be thought of as variables to define the command request. So, for example, if we wanted the drone to land in required precision landing mode, we would write the integer number 2 to the param2 field. And then all the data populates the command long message as before, and constitutes the data portion of the MAVLink message. Let's pull up the MAVLink message page that we discussed at the beginning and check out some of the standard messages and commands with more detail. Okay, so here we are at the MAVLink website. Let's check out command long. And here we go. So this is what we pulled from the slide. And we can see again the command field, and it uses the mav command enum. So let's look for the definition of this mav command enum. And you can find it because the mav command string will be one of the first references of that string. Okay, now here we go. This is the mav command enum. And we can see here, this is the value or the number of the command that gets mapped to the specific command. So we can see here, if we specified 16 in the command field of command long message number 76, we would be doing a mav command nav waypoint command. So we would be telling the drone to move to a particular place. And we would need to specify where the drone should move to, and that is done in param 5, 6, and 7 by specifying the latitude, longitude, and altitude coordinates. And this mav command enum is a very, very long enum, and each one of these numbers, as stated before, is indicative of a different command that we can send to the drone. So as you can see, there's a lot of commands that we have available to us to send to the drone. The one thing to note here is just because the MAVLink command is specified in the standard MAVLink message protocol, this doesn't mean that the software that receives the MAVLink message is prepared to appropriately handle that command. So some of these commands might not actually be available in the ArduPilot codebase, for example. We've looked at the MAVLink message number 76, command long, in detail. Let's check out some other MAVLink messages. Okay, here we go. We're starting at the top of MAVLink messages, and we can see here's MAVLink message number 0, which is the heartbeat message. And message number 1 is a sys status message, so we can get a bunch of information from the vehicle in one little standard message, like battery voltage, current battery. Here's param request read, which we've also dealt with in MAVProxy without knowing that we were using MAVLink message number 20. Just request a parameter that we want to know the value for. And most of them can be appropriately digested by ArduPilot, but remember, it is dependent on the ArduPilot codebase to enact the appropriate code when receiving the specific message to fulfill the request. So if the ArduPilot codebase receives message number 55, but it doesn't call the correct code to handle this message, then it's essentially not usable. MAVLink is only a message standard. It doesn't directly command the drone. It only tells the drone of our request. It is still dependent on the ArduPilot codebase to enact that request by calling the correct code.